LangGraph's interrupt mechanism enables dynamic execution, pausing within computational workflows, allowing for external input integration at precise operational junctures. This pattern facilitates human-in-the-loop validation while maintaining state persistence through checkpointing. We are about to examine a node implementation where an audit record creation precedes an approval interrupt, revealing critical considerations about idempotency in stateful operations. The code demonstrates how non-idempotent database operations before interrupt calls can lead to duplicate record creation during execution resumption.
Def node state. Hash bad, creating a new record before interrupt. Hash this will create duplicate records on each resume. Audited equals DB, create audit log. Userid, state user ID. Action, pending approval. Timestamp, data time now. Approved equals interrupt approve this change. Return approved audited.
This code demonstrates a critical issue with non-idempotent operations in interrupt-based workflows. The node function creates an audit log record before calling interrupt, which pauses execution and waits for user approval. The problem arises because when the graph resumes after the interrupt, the entire node restarts from the beginning, causing the audit log creation to execute again. This leads to duplicate records in the database on each resume operation. The pattern highlights why side effects should be placed after interrupt calls or made idempotent. In this case, the database operation isn't idempotent. Each call creates a new record rather than updating an existing one. The solution would be to either move the audit log creation after the interrupt or modify it to check for existing records first. This demonstrates a fundamental principle of interrupt handling. Any code before an interrupt call will re-execute when the node resumes, so it must be safe to run multiple times. The example serves as a cautionary case for human-in-the-loop workflows where external approval is required. While interrupts are powerful for creating approval workflows, they require careful placement of side effects to avoid unintended consequences like data duplication or inconsistent state. Let's break it down.
Def node state.
Defines a function named node that takes a single parameter, state, with type annotation state. The function signature indicates this is a node processor in a graph-based workflow, where state represents the current state object being passed through the graph.
Audited equals DB, create audit log.
Calls the createAuditLog method on the DB object, passing a dictionary as an argument to create a new audit log entry. The returned audit log ID is assigned to the variable audited.
Userid, state user ID.
Assigns the value of the userid key from the state dictionary to a new dictionary key also named userid. This copies the user identifier from the current state into a new data structure while preserving the same key name.
Action, pending approval.
Sets the action field to pending approval, indicating the current state or status of an entity in the workflow.
Timestamp, data time now.
Assigns the current date and time to a dictionary key named timestamp, using Python's dataTime now function.
Approved equals interrupt approve this change.
Calls the interrupt function with the string approve this change as its argument and assigns the returned value to the variable approved. This suggests the function prompts for user confirmation and returns a Boolean or similar result indicating approval status.
Return approved audited.
Returns a dictionary with two keys. Approved, containing the value of the approved variable, and audited, containing the value of the audited variable. This is a standard Python dictionary return pattern used to package multiple values for the caller. The interrupt mechanism in LangGraph creates a critical juncture where execution pauses for external input. But this power comes with a fundamental constraint. The entire node re-executes upon resumption. The audit log creation before the interrupt demonstrates how non-idempotent operations violate this constraint, generating duplicate records with each approval cycle. The pattern reveals that side effects must either follow the interrupt call or be designed to handle re-execution safely. This isn't just about data duplication. It's about maintaining state consistency in human-in-the-loop workflows where approvals may require multiple attempts. The solution space narrows to two options: reorder operations to place side effects after the interrupt, or implement idempotency checks in the database operation itself. Either approach preserves the workflow's integrity while leveraging interrupts for approval gates.
The audit log births itself before the question breathes, leaving spectral twins in the database.